Today we're doing lesson 2.5, that's module 2, lesson 5. And your learning goal is to explain how an area model is related to the standard algorithm of multiplication. So as you might remember, we've worked with area models before. Area models are those things where you have boxes and then you have numbers on the different sides and then you find the area of it by multiplying the two sides. Does that make sense? Okay. And a standard algorithm, of course, is when you write the multiplication problem like this and then you solve it. The regular standard algorithm means the quote-unquote regular way of solving it. We're going to see how these two things are related today. Does that make sense?
Yeah.
Good. Go ahead and write this problem in your notebook. 5 times 21. We don't have time for personal reminders today. You just need to write it down. Let's remind ourselves what the different parts of a multiplication problem are called. The 5 and the 21 are called what? Factors. And whatever the answer is called a product. Good. Go ahead and remind yourself by labeling those things. Okay. Does it matter what order the factors go in?
No.
So we could think of this as 5 21s, or we could think of it as 21 5s, right? Very good. Now, if we want to represent this problem using a tape diagram, if I have 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5 like that, how many 5s would I need? 21 5s, right? So I could show that there are 21 5s here. Don't you think? Right? Is this the only way to show it? I could also show 21, 21, 21, 21, 21 5 times, right? Yeah. The way I'm showing here, is it 5 21s or 21 5s?
21.
Is it 5 21s? No. What's my unit? 5. And how many of them do I have? 21. Okay, so what I'm showing here is 21 5s. Could I do, this shows I'm doing 5 plus 5 plus 5 plus 5 plus 5 plus 5. How many times?
21 times.
And we know that multiplication is the same thing as repeated addition. And is this repeated addition?
Yeah.
Very good. So do you agree that this tape diagram shows this problem?
Yeah.
Very good. Imagine that I took that tape diagram and I turned it sideways. Do you see how I rotated it? It was like this before, right? And now I rotate it this way. Okay, so rather than stacking my 5s across horizontally, now the 5s are stacking vertically, right? So I still have 5 plus 5 plus 5 plus 5 plus 5. How many times? 21. So that's like drawing a rectangle where the top side here is 5 and this side here is 21. Do you see that? Okay, so go ahead in your notebooks and draw yourselves a rectangle that looks like this and label it 5 across the top and 21 on the side. But we know that 21 is the same thing as 20 plus 1. So I broke it up actually into two smaller rectangles, a 20 and a 1. Does that make sense? Is this related to how we did area models before? Yeah. Now, if I want to find the area of this top smaller rectangle, I need to multiply the length times the width. So what's the length? It's 1, and the width is 5. So in order to find the area of that section, I would do 1 times 5. In order to find the area of the bottom section, I would do the length, which is 20, times the width, which is still 5, right? Because this width is the same as up there. So in order to find that area, I would do 20 times 5. Does that make sense? This is how we're going to write these area models. Now, I'm going to write the answer out here. So 1 times 5 is 5. So the area of this top part right here is 5. 20 times 5, I can think of 2 times 5, which is 10. And there's one factor of 10, so I can write there. So 20 times 5 is 100. That means the area of this part of the rectangle is 100. 5 and 100. Are those both products? Yeah. But are they the answer to 21 times 5? They're only part of the answer to 21 plus 5 times 5, right? So 5 and 100, we call those partial products. The word partial means it's only part of the entire product. So 5 and 100 are both partial products. So I want you to write the words partial products and show that those are partial products. If 5 and 100 are both partial products, how can I find the total product? Because these are only part of the total area, in order to find the total product or the total area, we need to add them up. So the total is 100 plus 5, or 105. Therefore, the total product for 21 times 5 is 105. Yes?
Yeah.
Good. This this is what we learned to do in 4th grade, but today we're going to take it one step further. You can see this is a 2-digit number times a 1-digit number. We're going to do 2 digits times 2 digits, or even 3 digits, and we're going to see how it's related to the standard algorithm. Now the directions tell us to draw an area model and then solve using the standard algorithm. It says to use arrows to match the partial products from the area model to the partial products in the algorithm. So start by writing this problem down. 34 times 21. And then over on the right-hand side, save some space, but then write the standard algorithm. 34 times 21. Okay. It first tells us to draw an area model. We know that area models start by drawing rectangles, right? So go ahead and draw a rectangle. And for today's problem, I want you to always look at the standard algorithm. What number is on top? 34. Whatever number's on top, we're going to put it over here, 34. Does it matter, by the way? Could we switch it? Yeah, but for today's problems, whatever number is on top of the standard algorithm, I want you to put it on top of your area model box. That means the other factor goes over here, 21, right? Okay. We're always going to, for today, we're going to keep the top number whole, so we're not going to split that number up, but we're going to split the side number up. So what's one way we could split up 21 to make it easier to multiply? Help me? 1 plus 20. Very good. So we're going to split that rectangle into 2 smaller rectangles with 1 and 20, because 1 plus 20 is 21. Okay. How can I find the area of that top blue section? I need to do the length times the width, so it'd be 1 times 34. What is that? What's 1 times 34? 34. So let's write that. Is that the total product? No. That's a what kind of product? Partial product. So we're always going to write the partial products on the side over here. You could even write an equal sign there if you want. Okay. Now, how do I find the area of this bottom part? It's 20 times 34. So 20 times 34. Now, we have a multiple of 10, don't we? So we can ignore this 0 for now, and we could do 2 times 34. What's 2 times 30? 60. What's 2 times 4? So what's 2 times 34? And then we had how many multiples of 10? So 680. 34 and 680 are both the partial products, aren't they? So how can I find the total product? I can add them together. So I can do 4 plus 0 is 4. 3 plus 8 is 11, and then 1 plus 6 is 7. So what's the total product? 714. Do you see how when I add the partial products up, I get the total product? Yeah. Very good. Now, let's turn our attention over to the standard algorithm. Think about it. You guys know how to do standard algorithm. What number would you multiply first? 1 times 4. And then you would do 1 times 3. But is it really 3 or is it 1 times 30? 1 times 30. So really what you're doing first is 1 times 34, aren't you? Yeah. What is 1 times 34? 34. Okay. And then when you're done with that, you would move on to the 2, right? And you would say, oh, I'm going to put a placeholder 0 there. Why do you put a placeholder 0 there? Gia? To change from 1 to 10. Because is this really 2? No. It's really what? 20. So really you're doing 20 times what? 34. Right? You're really doing 20 times 34. Right? You're imagining there's a 0 there. What is 20 times 34? 600. Do you see how we already did that? Okay, so when you do the standard algorithm, you're basically finding the different partial products to get to the total product. Does that make sense? Okay, so it says draw an area model, then solve using the standard algorithm. Did we do that? Yep. Then it says use arrows to match the partial products from the area model to the partial products in the algorithm. So here's the partial product in the area model, and here's the partial product in the standard algorithm. So draw an arrow to show that they're the same, just like that. Then here's the partial product for the second part. And look, is it the same as the one in the standard algorithm? Yeah. You got it. Okay, so you're going to draw those 2 arrows to show that those 2 partial products are the same. That's why it's very important today to make sure whatever number's on top in the standard algorithm to put it on top of your area model so that it will match up like that. Okay? So that's nice. This time, because our factor has 3 digits, 242, we're going to split it up. Okay? We're going to do 242 is the same thing as 2 plus 40 plus 200. Is this kind of like expanded form? right? So you're thinking about each digit and what unit it's in. Very good. Okay, how do I find the area of this top part? I have to do 2 times what? 21, which is 42. Very good. Okay, how do I find the area of this middle section? I have to do 40 times 21. Do I have a multiple of 10? So I can ignore that 0 for now, and I could do 4 times 21. What's 4 times 20? 80. What's 4 times 1? 4. So what's 4 times 21?
84.
And then I have how many multiples of 10?
1.
So I need to add 1 0. Okay. Now the bottom, how do I find the area of this? I have 200 times 21. It can be tricky to find out what this one is, but do you see how this length is always the same? Right? So it's 200 times 21. Do I have any factors of 10?
Yes.
How many? 2. So let's ignore them. I'm left with 2 times 21, which is?
42.
And then I have to add what?
2 zeros.
Okay. So which one's the answer? 42, 840, or 4,200?
None.
Why are none of them the answer? Eva? They're all part of the answer, right? You have to add them together in order to find the full answer. So what you could do is over here using standard algorithm, you could say 42 plus 840 plus 4,200. And then if you line up the place values, you can add them up and find that the answer is 5,082. Yes? Do you guys agree?
Yes.
Okay. That's only part of the work, though. Now let's do the standard algorithm. Think about it. When you're doing standard algorithm, what are you going to multiply first? You're going to do 2 times 1, which is 2. And then you're going to do 2 times 2, which is 4. Is that doing the same thing as 2 times 21?
Yeah.
Is that what we did over here, 2 times 21?
Yeah.
So you use an arrow to show that those are the same. Then you'd move on to the next digit, which is 4, right? But the 4 is in what's place? 10. So you have to put a 0 here to show that we're in the tens place now, right? So then you do 4 times 1, which is 4. And then 4 times 2, which is?
8.
So really what you did was 40 times 21, isn't it? Is that what we did over here, 40 times 21?
Yeah.
And we got 840 both ways. So do you see how the partial products are the same? Use an arrow to show that they're the same. Then we move on to the last digit, which is the 2. The 2 is in what place? What place? 100. So how many place value zeros do we have to add? 2, right? And then we do 2 times 1, which is? 2. And then 2 times 2, which is? So really what we did we do 2 times 21, or did we do 200 times 21?
200.
Hey, that's what we did here, 200 times 21, isn't it? And we got 4,200, which is the same as what we did there. So do you guys see how the standard algorithm is really just doing the area model?
Yeah.
It's exactly the same, isn't it? And then, of course, at the end, these are all partial products, so you'll add them up, and you should get the exact same answer, 5,082. The standard algorithm really is just the area model, because the area model, you're separating out the units, and then you're doing the units over here, one by one. See how all along you were doing it?
Yeah.
Very good. So when we do the standard algorithm, we start in the ones place. We're going to do 3, basically, times 123, right? Okay, so we do 3 times 3, which is? 9. 3 times 2, which is?
6.
3 times 3, which is? 3. So are we done?
No.
Are we only partially done?
Yes.
What part of the problem have we done? We've done 3 times 123, right?
Yeah.
What part of the problem do we have left?
20 times 123.
Supon, I loved the way you said what we have left is 20 times 123. Is it 2 times 123?
No.
It's 20 because the 2 is in the tens place. And so we can remind ourselves of that by putting a placeholder 0. It's like how we ignore the 0 at first and then add it later. Does that make sense? Now we can do 2 times 3, which is? 6. 2 times 2, which is?
4.
And 2 times 1, which is?
2.
That means that 123 times 20 is 2,460. Now, both of these are partial products, so in order to find the full product, we need to add it together. How many how many ones do we have all together?
9.
How many tens do we have all together?
12.
12. Be careful, it's not that we have 2, we have 12, but we're going to write 2 and then regroup them. How many hundreds do we have?
8.
And how many thousands do we have?
2.
2.